Hi guys, welcome to this video. Remember, it's always loud physics when nothing else will do. In this video, we talk about Ohm's law. If you connect a lamp to a battery, a current in the lamp causes it to glow. Now, what do you think will determine the size of the current that flows through the lamp? It depends on two things. The first one is the potential difference or the voltage across the lamp. If the potential difference is greater, then we'll have more current flowing through the lamp. Another factor is the resistance of the lamp. If the lamp has more resistance, then smaller current is going to flow through it. On the other hand, if the resistance is small, then we'll have more current flowing through it. If we put these two things together, it brings us to this whole idea which was coined into a law called Ohm's law. Before we state the law though, we want to go through a simple experiment which would help us to understand these 2 points that were mentioned earlier. Then we'll see how it is related to the law we are discussing, that is Ohm's law. In this experiment, here are the things that we will need. We will need a battery. We need a conductor, a wire. In this particular instance, we are going to use one made of nichrome. We need a voltmeter, ammeter, variable resistor or rheostat, then a beaker containing water. Let's look at how our setup is going to be. Our arrangement is going to be a series connection from the battery to the variable resistor or the rheostat, which will connect to a conductor made of nichrome. Then we'll have this connected in series with an ammeter, then back to the negative terminal of the battery. The voltmeter is going to be connected across the wire or conductor to measure its voltage as we vary the resistance of the variable resistor. Please note that the nichrome is going to be kept in water so that its temperature will be kept constant. Now that we know the apparatus for our experiment, how would we go about it? When a variable resistor is adjusted, we realize that the values of current flowing through the circuit as well as the voltage across this conductor will change. We are going to do it for a number of instances, and in each instance, we are going to measure the voltage across the conductor as well as the current flowing through the conductor. So these are values we get for experiment. When we have a voltage of 0.5 volts flowing through a conductor, a current of 0.1 flows through it. When the potential difference is 1 volt, current increases to 0.2 amps. A voltage of 1.5 volts increases the current to 0.3 in that order as shown in the table. If we are to divide our voltage by current in each instance, we get a constant which is 5 ohms. Now this value is significant. Plotting a graph of current against voltage gives us a straight line which passes through the origin. What does that tell us? From your knowledge of graphs, you know that if you have a straight line passing through the origin, then the two parameters are directly proportional. So current is proportional to voltage. Dividing voltage by current gives us a value called resistance. And the resistance that we found in each instance is a constant. What then does this tell us? What it tells us is that for a metal conductor, if all other parameters are kept constant like temperature, then voltage is going to be directly proportional to current. And that is exactly what Ohm's law is about. It states that the current flowing through a conductor between 2 points is directly proportional to the voltage across the 2 points when all other things are kept constant like temperature. And a conductor which obeys this law is referred to as an ohmic conductor. That brings us to the relation R is equal to V over I. We know resistance is when voltage is divided by current. If we rearrange, we get V is equal to I times R. And that is a mathematical expression for Ohm's law. Thanks very much for watching. See you in the next one.